In 3, 2, 1. And we are live. Hello, everyone at home. Welcome back to Cambridge University Astronomy, where we are crossing our fingers very much and hoping that we get a view of today's solar eclipse, which is happening over the UK. The eclipse itself is going to start in about 10 minutes, and then at 11:15 it's going to reach what we call maximum totality, where the moon is going to cover about a third of the face of the sun. I'm here with a range of observers all the way over Cambridgeshire who are going to be hunting for gaps in the clouds to show you some nice views of this amazing event. Luckily, we have nice entertainment on hand, even if the clouds persist. So even if we don't get to see the eclipse, which I hope we do, we're going to have talks all the way through the morning telling you about the history of eclipses, a bit about stars, and why people have thought that eclipses were terrible portents of doom. So we have a nice morning lined up for you. And hopefully we'll have some gaps in the clouds, so we'll be able to see some astronomical goings on. Like I said, we have a range of observers all the way over Cambridgeshire who are going to be live streaming their telescopes for you this morning. I think the first thing to do would be to go around and meet our observers and have a little chat about which telescopes they're going to be using. So first of all, we're going to go over to Dr. Robin Catchpole, who is at the University of Cambridge, and he has a rather unusual instrument he's going to be using to see the sun. Robin, are you there?
Yes, I'm here. Can you see me? Do you want me to screen share? That's what I have to do, is it? Yes.
No, so I think we can see you perfectly. So yeah, if you just take your webcam and
will they? I mean, if they will see more than just a tiny little icon, will they? Yeah.
Yes. Yeah. We can see you. We can see you perfectly, Robin. Full screen.
Okay, well, welcome everybody. I'm actually at the Institute of Astronomy inside our 16-inch telescope. And in fact, I'm below the level of the telescope in a room without windows and a hole in the wall. And outside should be standing on the bracket this instrument here, which is a heliostat. In other words, I think I'm looking at it. I just have to check my little screen here that I can see it. Yeah, it's hidden it for me. This device stands outside on the wall. It's called a heliostat because it keeps the sun still. And the idea is that it's made of two mirrors. This top mirror follows the sun around the sky and shines light, reflects light onto the second mirror, which sends it through a hole in the wall. And the sunbeam comes through the wall, and the hole in the wall, I don't know if you can, let's see if we can see the hole in the wall. You can perhaps just see the lens, which is mounted on the inside. Again, I'm not quite sure what I'm looking at. Can't quite see it from here. I think, well, let's move the camera around. You can probably see it now. I have a slight disadvantage. I can't see what I'm pointing the camera at, but it comes through a hole in the wall, and then we have a very long focal length lens. It's got a focal length of about 12 feet, and it goes to a secondary lens, which is just, you can see at the end of the optical bench here. This lens focuses the image, which is formed 12 feet in here, and will project it onto the white screen. Not sure if you can see the white screen there behind the pillars. So that's what I intend to do. And as soon as the sky clears, I will nip outside and put the heliostat on its bracket. Well, hope to chat to you a bit later, maybe when we've got something to show you. Okay. Cheers, bye.
Thank you very much, Robin. Yes, I think this setup in particular is going to be very nice because instead of looking through a telescope at the sun, we're projecting it onto the wall. So even if we have some clouds drifting over the face of the sun, we should get some very nice views.
Yes.
Who would like to go next?
I'm going to hand over to one of our observers who's actually outside. And that's Jonathan.
Thank you, Paul. I'm Jonathan Clough. I'm actually at the other end of the spectrum from Robin in terms of technology. I'm actually starting with the very basic thing, which is a pinhole made in a piece of cardboard with a bit of foil in the middle. And I'm hoping to do what Robin was doing and project that onto a little screen, but that's the basic level. But my main observing technology is over here. I'll move you across. So this is a 6-inch simple reflecting telescope. The light goes in at the front of the telescope, goes to the back of the telescope where there's a mirror, and then reflects back up there to an eyepiece. And you can see the eyepiece assembly up at the top here. And you can see that I've got high technology here. I've strapped my mobile phone to the eyepiece, and that's currently looking for the sun, but there's nothing to see because of the clouds. Now, this is a very simple setup. This sort of telescope costs maybe £200. It's not got any clever controlling things. So if we do get the sun through the clouds, I'm going to have to be adjusting the position of the telescope to try and track the sun. So I hope you'll bear with me on that. And this is a typical back garden telescope. So hopefully we'll see something with all of these telescopes later on.
Thank you,
Jonathan.
It's amazing we can use just the technology that we have nowadays to be able to do this is absolutely amazing. A setup that would have been, cost an absolute fortune 20 years ago, we can now just do with a phone in the backyard. It's absolutely amazing.
Okay, well, I'll go next, shall I? If I can unpin your image from the screen. I can't get rid of, it's not coming over to me, but that's interesting.
It has come to you, Paul. You just can't see yourself.
I just can't see it. Okay, yeah. Thank you. Right, so I'm Paul Fellows. I'm the chairman of the Cambridge Astronomical Association, and I'm sitting in my observing station, and I have a telescope outside. Let me see if I can show you that. If I go to here, this is my telescope in the observatory down at the bottom of my garden, which I'm controlling remotely at the moment. It's in a classic dome-shaped building with the slot open. You can just see that at the top there, and it's pointing up towards the sun. It's got a couple of cameras mounted piggyback on the top of it that you can't see. They're hiding behind the main tube. So the main telescope is being used.
Yeah, we're doing our.
And we'll be gathering images from those once the sky clears, hopefully. Now, I was just going to show you what's going on sky-wise. If I share my screen over here, we've got the camera on the roof of the Institute of Astronomy. It's got a certain amount of dirt on the top of the cover there. That's what those black specks are. But I'm afraid what we're seeing at the moment is large amounts of cloud. And in the satellite image taken from space, the little crosshairs are marking where we are. And you can probably just about see that the cloud is moving away and there is a gap coming behind it, which we hope is going to arrive and release us to be able to get some images. So that's what I'm trying to do with my specialized cameras mounted on the back of this remotely operated telescope. So I will now hand over to Mick Jenkin, who is at a different location. Where's Mick? Let's there's Mick. You're live, Mick. Tell us about your equipment.
Good morning to everybody. It's Mick Jenkins. My location is Swaffham Prior, which is east of Cambridge. I've got a picture on the screen. I'm not sure whether you can see it.
Yes.
You can see it.
Yes,
that's the tripod, which is a Skywatcher AZ EQ5 with two telescopes. I should be using the left-hand one, the 80mm one this morning, with a Herschel wedge for getting a nice image of the sun in white light. I'm also going to use, if we can, a Solar Max 2, which is a hydrogen alpha telescope, which just shows the sun in hydrogen alpha, which is a very narrow wavelength, which will show prominences on the edge of the sun, and also any detail on the surface. I'm just going to unshare this one. Right. Okay. That's about it, Paul.
Thank you very much, Mick. Well, we hope to get some images from you in maybe 20 minutes or half an hour when this break arrives. I think it's going to arrive at my location to the east of Cambridge first, and probably then Robin and Jonathan will get into the clear, and I think you're going to be last. So you've got a little bit of time to wait before we'll come back to you. So at this point, I think we're going to hand over now to Brian Lister, who is going to actually give us a little bit of a talk from a historical point of view about other eclipses. But just before we do that, Jonathan, do you have that feed of the eclipse as it's happening now live?
I do. I was about to suggest I'll flick it onto the screen now. Bear with me a second.
This is an image from America that's hopefully Jonathan's going to share with us.
What's it gone? There we go. Are you seeing that?
We are.
And this, I think it's actually from northern Canada. I'm not sure if America's under the path of totality, but this is showing you the moon in the top right-hand corner starting to gradually move across the surface of the sun. This eclipse, it says at the bottom, is a ring of fire eclipse. So because the moon in its orbit is currently one of its furthest points from Earth, it's actually a bit smaller than the disk of the sun. So we will see a very spectacular eclipse. So sorry, we've gone to adverts again, so I'll stop sharing that.
Thank you, Jonathan. Okay, so we'll hand over now to Brian, who's going to give us a little bit of a talk about some history of eclipses, and from the point of view of a man called Professor Todd, who had a lot of bad luck with it. And we'll let Brian get his presentation going.
I'm having
He's lost it.
Yeah, I've lost it. I'm sorry.
Okay,
right.
Brian.
We're there, are we?
We are.
Good. Okay. Well, it must have been terrifying for the ancient people to see the familiar object like the sun gradually disappear. And of course, there were always explanations given, whether it was usually something eating the sun, whether it be dragons, bears, jaguars, giant frogs, wolves, that was the Vikings versions, or snakes. But whatever happened, you tried to get rid of it. And some cultures, they fired arrows into the sky. Others lit fires to reignite the sun. But most would just make noises, bang pots and pans to frighten things away. But of course, an eclipse doesn't last very long, so all their efforts succeeded. So the myths carried on that you should carry on banging things when an eclipse occurred because it would scare things away. But the one culture that really understood it were the Aborigines. They saw the eclipse as an amorous embrace between the sun and the moon. And they even had stone arrangements, small scale versions of Stonehenge that helped them understand the motions of the sun and moon and the seasons. Had more or less the same purpose as Stonehenge, but some of these stone arrangements in Australia go right back twice the age of Stonehenge. But they've always been, eclipses have always been associated with bad things that have happened. the most important things were to an emperor was obviously astrology. It would figure in how he was succeeding as being an emperor, his health, and whether things should carry on. But if an eclipse occurred, he needed to know. And that was why there were many, there were often emperors who had court astrologers to look out for these things. And there is a legend of long ago, two astrologers, Thai and Ho, who unfortunately failed to predict an eclipse of the sun. And it is said that they met a very sticky end with their heads being lopped off. But all throughout history, people have said that various of events have been predicted by eclipses or have resulted in eclipses. Like Henry I died shortly after the sun produced, or the sun was eclipsed and produced a hideous darkness in 1133. But actually, when you check out, he died in 1135. So there's a lot of jiggling of the figures that went on. And taken that there are 2 to 5 eclipses of the sun each year, as well as about 3 eclipses of the moon, add in some passing comets, and you can also always associate some misfortune with one of these events, especially as you're fairly liberal with the dates. But one event that did happen in Turkey was caused by a total solar eclipse, when the sun is totally covered by the sun. This eclipse we're seeing today is would be an annular one. The sun is just slightly bigger than the size of the moon, so you get a very thin ring of the sun. But in this eclipse in Turkey, the Medes and the Lydians had been fighting for 6 years, when during a battle an eclipse started. And of course this caught the attention of everybody, and they stopped fighting. And there was a hastily organized truce. And a good sort of thing that happened was that the truce lasted, and there was even a marriage between a royal marriage between the two parties, and it was a success story. So not all eclipses have a bad outcome. But later on, we started to understand what the sun was and what eclipses were, and we looked into the science. And the first scientific expedition to observe a total solar eclipse, when the sun is totally covered by the moon, was way back in 1780, when Samuel Williams wanted to go and observe in what is now Maine. Unfortunately, this was in the middle of the American Revolution, and Fort George was where he wanted to observe from, was been taken by the British. And the Americans, although they'd tried before the eclipse to recapture it, hadn't succeeded. So there was a lot of diplomacy, and eventually Williams was able to get an agreement from the British commander of Fort George that he could go and observe and he wouldn't be harmed. So he and several other scientists with their telescopes and equipment were given a small island to observe from, where they could observe the eclipse. As the time of the eclipse approached, the sun became a thin sliver, But just as it was about to be covered, it started to uncover. As you can see from the top left picture, there's a drawing done by one of the expedition members, and you can see that the sun is not quite covered. And we've got what's called Bailey's beads, and they're little bits of sunshine peering through the gaps in the hills and the mountains of the moon. And below is a modern photograph of Bailey's beads. What he'd done, he'd got his calculations wrong. He was 50 miles south of totality, or 50 kilometers, sorry, south of totality. So they didn't see the corona, because this is the outer atmosphere of the sun that they wanted to see. And this is what can only be seen during an eclipse. Many years later, the discovery of helium was found by Pierre Janssen, observing a total solar eclipse from India. He was able to get a spectrum from the corona and found a particular absorption line in the yellow part of the spectrum of an unknown element. But by coincidence, Norman Lockyer in Devon, a month later, was able to find the same part of the spectrum, the same absorption line, from his observatory, using a spectroscope, which you can see it has 6 prisms on it that disperses the light into a spectrum. And he also found this unknown element, and they both sent their information to the French Academy of Sciences. And although they had discovered it a month apart, their letters arrived on the same day. Some say within a few minutes of each other. And so they're both credited with the discovery of helium in the sun. That same eclipse, King Mungat, who ruled Siam, he was great at mixing both traditional and modern. He was very interested in science and technology, and he modernized Siam, introducing things like telegraphs, and he worked out that the path of totality, which is just a few miles wide, would pass across Siam. So he organized an expedition there. And as you can see, he had a lot of children. As some of his 82 children are photographed there. And of course, he had a teacher come along, Anna Leowens, and she looked after the children. And it's what was the film The King and I was based on, with Yul Brynner, which is still banned in Thailand. Here we see a couple of photographs of the dignitaries waiting for the king to arrive. The bigger picture shows King Mungat. He's obviously the one sitting highest, while the peasants are the ones groveling low down. And he and many of his family observed the eclipse. But there was a problem. He had got his observing site near a swamp, and tsetse flies caused a lot of people to become ill. And both King Mungat and his eldest sons, photographed there, died from the result. And the picture shows his funeral during that after he'd suffered from dying from malaria. And so as far as his eclipse was concerned, it was a bad omen for him. But the first great American eclipse was when the path of totality went right across the country. And there were numerous scientific expeditions set right across the country to observe this phenomena and get good to find out about the corona. Here we see in the photograph, we see Thomas Edison, who's second on the right, with an expedition set to Wyoming. And the people from the East came over in thousands to be in the plains to observe the eclipse. And they in this particular area, you can see the ground is still wet from torrential storms. So not only were there storms, but in the more remote parts of the plains area, there were threats of Indian attacks. So it wasn't a very good area to look from. Here in Texas, we've got another expedition, and you can see it's by the shadows, it's very clear. But just 50 kilometers away, Professor Todd set up his equipment with his other observers. He'd organized an expedition, and his mission was to photograph the corona. But unfortunately, it was cloudy just that short distance away. He could just barely see the sun, but could do no science and take no photographs. Another eclipse, this time in Russia, with Dmitry Mendeleev, a rather eccentric scientist, but he had an idea of getting above the clouds. He would go up in a hydrogen balloon. Here we see it just before launch, but the trouble is the rainy drizzle had made the fabric of the balloon absolutely drenched it and made it so heavy that he and his pilot, Lieutenant Kovarenko, couldn't take off. They threw as much as they could out of the gondola, and no, it still wouldn't take off. So Mendeleev, not wanting to miss the eclipse, asked the lieutenant to leave the gondola, and the hydrogen balloon took off, and he observed the eclipse. Now came the problem of flying the balloon. Well, he knew it in theory, but he wasn't a pilot, so he had to learn on the fly, as it were. And when he pulled the cord to lower or let the gas out and lower himself down gradually, it snagged. So he had to climb out of the gondola and free the rope. And he was knocking on, he's well into his 50s at this stage. And but he managed to free the cord eventually. But he'd gone very high and got very cold, but he survived. But in the same eclipse, our friend, Professor David Todd, this time with his wife, Mabel, had set up an eclipse expedition with about 8 members in his equipment, setting up his equipment and many telescopes in Japan. And this time there were clear blue skies as the eclipse approached. But the slight problem was he was not very far away from Mount Nasutaki, which just happened to be a volcano. And as the eclipse approached, steam and smoke started to belch out of the volcano, followed by ash. And the eclipse was totally clouded out by this eruption. So another failure for Professor Todd. But he didn't give up. These eclipse expeditions would often take a year to plan, and they'd take 3 months because you'd have to go travel by ship, transporting your equipment. And he set up his station in West Africa, and an eclipse is only a few minutes, so you need to take as many photographs as you can. And Professor Todd is standing in front of the box, which is his communicator, which is pneumatic and sends the air pressure down all the tubes to operate the various cameras on his 23 telescopes he'd got set up. So he could take as many photographs as the corona as he possibly could in that short time. But it was cloudy again. But he used the opportunity to test his equipment, and he took over 300 photographs in 3 minutes. So that proved it worked, but it was another major disappointment for him. He went to Japan, back to Japan, and this time he'd changed his communicator to operate the telescopes to an electric device, and as the drum rotated on the device on the right, it made contacts that opened and closed shutters on the telescopes. But again, it was clear in the morning, but as the eclipse approached, the cloud gathered and it was clouded out yet again. Often you find with eclipses, the temperature drops dramatically by 10 degrees or more. Professor Todd did wonder whether the temperature drop was something to do with the clouds condensing out of the moist air. So that's his 4th failure. His next expedition was to Tripoli. And at last he had clear skies and was able to take many photographs. But unfortunately, the sun was particularly boring. As you can see, there's very little structure in the corona. But he also used this opportunity to get forewarning of any things he should look out by telegraph. Georgia sent him the information, anything he should look out for. But as I said, it was rather a dull eclipse. And these photographs were all taken by Mabel. And here's one of his larger telescopes set up in the French consulate, where he based his observations and put all his equipment, along with his where his other expedition members helped him. And the photograph on the right is a shadow of a tree, but it's acting like a pinhole camera. And this is the effect that Jonathan will hope to show you. And you can see lots of crescent suns shining through the gaps in the leaves. And you've got this wonderful effect of this was just before totality. So hopefully Jonathan will be able to reproduce this effect. His next expedition was to Indonesia, and this time he was worried about the clouds. He'd had 4 out of 5 failures. So he spread his telescopes over a number of islands, and he was at the red location, and he was hoping that if it did cloud over, at least one of the observing sites would be successful. But it clouded over, and 6 of the 7 were totally covered. The top observing site did have a camera there, but it wasn't attached to a telescope. And it was able to take just a few photographs of the corona, but because it wasn't through a telescope, it wasn't very detailed and not much science could be obtained. He went back to North Africa a few years later, and this time, as with his previous trip to North Africa, it was clear. And he managed to take over 265 photos in the 3 minutes of totality. But again, look at the structure of the corona. Absolutely nothing. But Mabel was always on hand to take photographs. And I rather like the one of the minaret. You've got people, this is taken during the eclipse, and you've got people up in the minaret all staring up at the sun. And she gave talks when she was in back home in America, and they became very popular. So she would often give up to 60 talks a year about her adventures to these foreign lands. His next expedition was not to observe an eclipse, but to observe Mars. He dragged that thumping great telescope up the Andes, and that telescope weighs about twice as much as that locomotive. And just for a 3-week period, and they took it up fairly high, as numbers of the expedition suffered from altitude sickness. And we can see Mabel and David are the ones sitting on the right of the telescope. And it was because Mars, it was the closest approach. Again, he took a lot of photographs, and Mabel did amazing drawings with through this telescope. But it took a prodigious amount of effort to get it up there. But because of the success of Mendeleev and others going up in balloons to get above the clouds, because he'd been plagued by so much bad weather, he and 3 other scientists went in a balloon to observe Halley's Comet that came by in 1910. And up they went, but the cloud bank was so high they just couldn't get above it. So another failure for Professor Todd. So he decided to scale this next expedition down to Russia, scale it down to just 3 people, rather than his 8 to 10 other scientists that went with him. It would just be him, Mabel, and their daughter, Millicent. The plan was just to go out and arrive in Europe, hire a French plane and pilot, and fly above the clouds once they get to Russia. I rather like this picture that appeared in the Virginia Chronicle. It shows Professor Todd sitting like on a balcony of in front of the plane, casually leaning back with his camera in hand. That wouldn't have been how it appeared. But as he arrived in Europe, it was the start of the First World War. Germany was just being invaded by Russia. He turned up and saw what was happening and just decided to give up. At any rate, his equipment had got lost in transit, and he decided to return as quickly as possible. But the main problem was was getting back. There were just trains were cancelled, and it took him weeks and weeks to get back via Scandinavia. And in America, you can see from this newspaper cutting, they thought he was lost in Russia, but he never even made it into Russia. He was just out of the loop so long. His next expedition was another one where the path of totality went from coast to coast across America. Originally, he was going to observe in Oregon, where the green dot was, where he'd get 2 minutes of totality. But in the end, he left it rather late, and he set up in Florida, where he would only get 50 seconds of totality, but he nevertheless set up all his equipment. And all along that path, there were dozens and dozens and dozens of scientific expeditions to observe the totality. And as you can see, it's clear in Oregon. And in fact, it was clear in all the observing sites bar 2. And you can guess where he was. He was under cloud in Florida. The Sunshine State didn't live up to his name. And it's a shame, really, because if you look at a drawing of the corona, you can see there's a lot of structure there. His final eclipse was to Brazil. This was going to be nearly 7 minutes long, and that's just there are not many eclipses where totalities are over 7 minutes. And this eclipse, there was an enormous solar prominence. I've added Jupiter to show you the scale of this huge prominence that appeared during the totality. But I'm sure you're already guessed what's happened. The weather thwarted him yet again. And the newspaper headline proclaims, Professor David Todd loses his eclipse plane. The machine is wrecked in a hurricane after having been landed in Brazil. Again, he was going to fly above the clouds, but that was only half the story. The ship he was traveling to Brazil on broke down. And by the time they'd fixed it, the eclipse had come and gone. And that was the end of his eclipse expeditions. He became mentally unstable. It was said that it had so much disappointment that it affected him. And so he'd had only 2 successes out of all these expeditions. A very, very unlucky man. And that's where I'll leave it.
Well, thank you very much, Brian. I'm beginning to know how he feels, and I wish we'd organised an aeroplane or a large balloon to take us up and get above these pesky clouds. I'm just going to show you where we are from the point of view of the all-sky camera here on the roof of the Institute of Astronomy, showing clouds. There was a brief moment about 10 minutes ago where it brightened up, but it's back to solid grey again. I could almost see the sun. And if you look on the satellite image here, where Cambridge is with the little crosshairs, that was us just going through that little tiny gap there a few minutes ago. This image is slightly delayed, and I'm hoping that this gap here is going to give us some clearer views as we go on. But let's now just see what other people can see. Jonathan, have you got the feed from America?
I have, yes. I've checked.
They've got a better view than we have.
It's actually from Canada. It is North Canada. I've checked. Let me share it with you. It's going quite well. So that should be sharing with you. I think you can see the time on this one, 9:45. I think it says in the scrolling thing at the bottom that their totality is actually very similar to ours. It's at 10:10. I think here comes. So it started at 9:02, and it's going to be in its totality at. No, it's not going to tell us there, but I think it's about 10:10. So in about 25 minutes, the moon will have completely covered the disk of the sun, and we'll see this ring going around it. So come back to this feed in about 25 minutes.
Yeah, that would be excellent.
I did forget to mention when I was talking about my telescope, it's the importance that it's not just the telescope sitting here doing its thing. It's actually got a proper solar screen on the front. So if you do have a home telescope, don't just go out and point it at the sun. This has got a solar filter on the front, which means the image is very, very dark. If you pointed your telescope directly at the sun without one of those, you do significant damage to your eyes. I forgot to mention it before.
Thank you, Jonathan.
Yeah, I think it's worth maybe putting out a general thing which we didn't say at the start. We assume that everyone would know by now, but yes, never look directly at the sun, whether it's with your eyes or with a telescope or anything like that. Those of you that were ahead of the game and found yourself some eclipse glasses that block out almost all of the lights, it's safe to do that if you're being very careful. But yeah, it should go without saying that looking at the sun is really not something that you want to do.
Thanks, Matt. Yes, it must be said that all of us have got very specialised equipment. Robin with his heliostat and Mick with his solar telescope that only looks at one wavelength of light, all of which are custom designed pieces of equipment for looking at the sun. Jonathan there with his extra filter on the front. That's a safe way of doing it as long as the filter's in good condition. Sadly, of course, at the moment, we can't see anything at all. So I think we will probably proceed now. And if I can hand over to you, Matt, to give us a little bit of a talk about stars in general.
Yeah, I think that's a good idea. Yeah, so I will talk about stars. I think maybe if I talk about stars and then we'll pause. I think I could talk for maybe half an hour or so just about the light, a bit about stars, about how they form, how they die. I don't want to talk over the totality. So I mean, obviously introduce me if
I will interrupt you at the right moment. Don't worry.
Interrupt me if there's a gap in the clouds, and yes, interrupt me if
as we get just after 11. Yeah.
Exactly. Yes.
Yeah.
And now let's do this. Can you see that? Okay.
That's great. Thank you.
Wonderful. Okay, so what I want to do is talk about the lives of stars, because obviously today what we are doing is when we're looking at the eclipse, we're looking at the moon, which is a lump of rock passing in front of the sun, which is our closest star. I don't know about you guys at home. I often don't think of the sun as a star. I mean, obviously we all know that the sun is a star, but it seems a bit of a trick, right? They seem so very different. The only reason the sun seems so special to us, of course, is because we're very, very close to it. Every single star that we see in the sky is a sun in its own right, and many of them have their own solar systems. If you could pick a star at random and get in a very fast rocket and travel to it, eventually it would get big and bright, and it would look like a sun, just like our sun. So our sun is in fact about as middle of the road and boring and ordinary as a star can get. So what I want to do is talk a little bit about stars in general. I'm going to start off with talking about how just some stars around us, right? Because when we think of our sun being the nearest star, a lot of stars don't look much like our sun. Like I said, our sun is about as boring and middle of the road as stars get. A lot of stars are a lot more weird and wonderful than our sun. So our sun, of course, is the nearest star to us. It's about 150 million kilometers away. And of course, it gives you an idea of how fearsomely hot and luminous the sun is, when something 150 million kilometers away can still give you something of a serious burn. But when we want to look at stars other than the sun, we really have to pull the camera back and zoom out quite a lot. So this is a little diagram of our solar neighborhood. So starting outward, going outwards from the sun, the first thing we reach is the Oort cloud. So the Oort cloud is a big sphere extending out almost a light year from our sun, which is where comets come from. So the Oort cloud is a big swarm of millions and millions and millions of comets that live in the absolute outskirts of our solar system. But then you carry on through the Oort cloud, and then you reach this star here. And this is the closest star to our solar system. It's called Proxima Centauri. It's a very little star in the Alpha Centauri system. So Alpha Centauri is a reasonably big, bright star we can see very easily. Proxima Centauri is a much smaller star that is in the Alpha Centauri system, but just squeaks in as the closest star to the solar system. It's much, much smaller than our sun. So if I show you in comparison how just the relative size between Proxima Centauri and our sun, it really is quite surprising. So this is our sun. And then on the same scale, this here is Proxima Centauri. Like I said, much, much smaller than the sun. And so if we take our sun as the yardstick, like the most middle of the road, boring star, average star that can be, this makes Proxima Centauri a tiny little red dwarf star. Stars get a lot bigger though. Our sun is on the small side for stars. Proxima Centauri is very, very tiny. A lot of stars that we see in the night sky are much, much bigger. This is Rigel. This is one of the bright stars in the constellation of Orion. And this star is absolutely enormous. This is a blue supergiant star. Comes in at somewhere around 100 million kilometers from side to side. If I show you the sun on this scale compared to Rigel, it starts to look pretty tiny. So this is this blue supergiant Rigel. And then this is our sun, which you can barely see. It's this tiny little orange dot next to it. That's the scale of our sun next to this very, very big star indeed. And
Matt,
yes, Paul.
I'm going to interrupt you because I've got an image.
Oh, I've never been more happy to be interrupted. Let's go look at the sun. Someone in the chat says clear skies in Ramsey, apparently.
Yeah.
So there are places in the UK that can see things.
Can you see this?
We can, yes. That's the
old. We've got this. The orange is like the disk of the sun, and a big bite taken out of it. I'm just going to fiddle with the settings a little bit. Let's have a little brighter. We've got a little bit of cloud going in front, which is why it's fluctuating. But that bite taken out of the sun there, that is the moon gradually moving across. Let me try and get it a bit better for you. There we have it. Yeah, so there's the disk of the sun. There's some clouds just scooting across, but you can see the big bite taken out by the moon. Can you hear me okay?
Yeah, that's excellent, Paul, and we can see it as well.
Loud and clear. Right. That looks spectacular.
Yeah, that's with the solar telescope that's mounted piggyback on the 14-inch reflector. So it's about a 2-inch diameter telescope, but it's dedicated to looking at the sun. I'll try and center that up for you just a little bit. This is where it all goes horribly wrong when I try and move things. But let's do that. I'll slow the speed down a bit and just nudge the telescope. Everything's of course upside down, so that's gone the wrong way. Let's bring it down this way. And across into the middle of the screen a bit. So we can see the full chunk taken out of the sun there. Now, I can't see any other features on the sun at the moment. I think I'm perhaps not quite perfectly focused, but the good news is that the sky above me is now 50-50 cloud and blue, and so the other observers will be able to join me in a few minutes, and that'll be perfect timing for the best of the eclipse.
That's an absolutely gorgeous view, Paul. It makes me so happy to see this. It's so awe-inspiring seeing the clockwork solar system actually happening in front of your eyes, right? Just knowing that that's the moon obscuring our sun, kind of drifting past in real time in front of our eyes as we watch it. It's kind of awe-inspiring. I'm never going to get tired of watching things like this.
There's the clouds again.
I can see a patch of blue approaching Chesterton now. I don't know how big a patch it is, but it's coming this way.
It's huge. You better get to action stations, Jonathan.
Yeah, yes. I will do. The other thing is that the full eclipse from Canada will occur in 5 minutes. Okay.
Well, we'll just stay with this for about another couple of minutes, and then we'll go to that. It is an amazing coincidence, isn't it, Matt, that the moon and the sun are almost exactly the same apparent size.
Right, exactly. So yeah, the sun is about 400 times bigger than the moon, but it's also 400 times further away, which makes them almost exactly the same size in the sky. That is a complete coincidence, and it also won't that won't stay the same forever. The moon's actually getting further and further away from the Earth at a couple of centimeters per year, about the same rate that your fingernails grow. So if you could fast forward a few 100 million years, or maybe 1,000 million years into the future, the moon will have got so far away from the Earth that we would not have eclipses anymore. So we are very lucky to live at this very special time and space where we can see these eclipses. I know some science fiction authors have suggested that having eclipses is such a rare thing that in the far future, maybe if humanity kind of spreads through the solar system, the Earth might remain a bit of a tourist destination because we are one of the few places in the universe where we get to see eclipses.
I've moved over to my SLR camera, which
we've got an image here.
Okay, let's go to Robin.
I can't see myself on screen. I need to see my image. There we are.
Yeah, we can see you, Ron. That looks wonderful.
See my image, and can you see, you can see the rim of the moon.
Yes.
It's not completely smooth. You can see the crater, the rough edge of the moon there.
Yeah, that's wonderful. So this is Robin at the University of Cambridge with the heliostat. So he's projecting an image of the eclipse onto the screen.
On the screen, and just to prove it's really projected, if I put my hand there, you can see the shadow. So we have an eclipse, yeah, and it's looking quite impressive. There's a tiny group of sunspots. You probably won't be able to see them just there. 1, 2, 3, 4, and the cross here is just on the bit of paper. So there you are. We've got the eclipse. I'm so pleased. And you can see bits of cloud streaming past occasionally.
This is spectacular, Robin.
Yeah. No, well, thank heavens, all yesterday's efforts were not in vain.
I'm glad we didn't just stare at clouds for 2 hours. This is perfect as well. This is very close to maximum coverage, and we have beautiful views.
Yeah.
Yeah, no, that is. Yep, and you see bits of cloud. You'll see. I mean, the problem I've got is that the image is much bigger than the lens that's focusing the sun. So if I do that, then I get rid of some of the background that's coming through. Because it's now the sun itself is getting faint because the cloud is blowing past. It is possible to change the optical assembly for cloud viewing rather than sun limb viewing, but this is the best quality image of the edge of the sun.
It is. It's a little bit overexposed, Robin. It's hard to see the edge right now.
Oh dear, yes. This flipping. That's the problem with these cameras. Oh yes, it does look rather overexposed.
Was there a lens or something that you took out of the optical path?
Was it not overexposed initially?
No, it was looking fantastic initially.
Yes. No, I haven't done anything. It's this blessed stupid camera thing that works. What does it do? It automatically gain controls and so on. But I do have a bit of software for trying to change that.
Paul, do you mind? Have you pinned Robin to the screen?
I've tried to, yes.
Okay, good. Thank you.
What I'm going to do is just do a quick, see if I can get the camera settings changed a bit.
We seem to have lost him.
Right, let us do advanced. Yes, it's looking really bad. Brightness, turn the brightness right down.
Okay, well, it's 11:01. Jonathan, what's the situation with the Canadian view? We'll come back to Robin in a minute.
Yes, I don't know if Robin's any better. Yeah. Oh, that's nice. The Canadian view. Yeah.
That's the view from Canada. So it's coming up to the point where we'll get the ring of fire in just 5 or 10 minutes time.
The trouble is now it's it's imaging. If I show you one bit,
Okay.
You'll see it's imaging the sky.
Yeah, and I'm trying to get some images here now.
So if you look there, you see, guys, you can see. In fact, that's almost a better way of seeing it when that's the prime focus, if you like, and you see the clouds steaming past. Yes.
All we can see of you at the moment, Robin, is your picture for some reason.
Right. Well, if I show you, I can show you a different view. Now, I don't know how that looks. What I'm doing is this is the prime focus.
Robin, it seems like your camera isn't working right now.
Yeah.
Oh, it isn't working, not at all.
Yeah, your
camera's not working. Okay. Oh, you just see me. Yeah.
I can just see your face. There we go.
Right. No.
It flicked on, then off again. There we go. It's back.
There. Can you see that?
Oh, we can see the clouds drifting past. That looks wonderful. Yeah.
Yeah. So what I'm doing now is just holding a piece of paper at the, as it were, the prime focus of the system, because when there's a lot of cloud, a lot of the light is getting around the lens and fogging the screen. So, yeah. So that is that's rather beautiful, isn't it?
And look, it does look rather, yes, it looks rather cinematic. Oh, there we go. We can see the sun poking through the clouds.
Yes.
Oh, beautiful.
Not the ideal setup because the camera isn't in the ideal position for this, but you get the idea, I think, of what's going on. Whoops, and there it's fading away, almost.
How's it looking for our other observers? Jonathan, it looks like you have some blue sky over there.
I think Jonathan's just trying to lock onto his image.
Right.
I'll show you what I've got for a moment while Jonathan gets perfectly set up.
I think
I've got
a completely different setup now because it's cloudy.
two images here, side by side. I've got the small image. No, the cloud's gone in front of it, of course, but it's coming back. The small image here is the white light view. Well, it would be if the cloud would get out of the way. Typical. Okay, I can't see it now. Sorry, I'll have to stop.
Well, it's probably as good as it got. In cloudy weather.
Robin, do you mind muting yourself while you're not talking?
Oh yeah, okay.
Cheers, thank you.
Muting myself.
Mick Jenkins, have you got anything for us?
No, I've got 100% cloud still.
Okay, the gap will be with you soon, I think.
I'm all set up, ready to go. Which would you
I've
prefer?
just got another naughty piece of cloud has come across in front of my view from here. Jonathan, what have you got?
Would you prefer white or hydrogen alpha?
Yeah, I've got a view, Paul, and I'm showing it.
Right, I can see you. Let me see if I can
see my telescope.
There's the view through Jonathan's telescope. This is taken with his 6-inch reflector and a mobile phone actually as the camera. So we can see the everything's not perfectly lined up, but we can see the sun. Oops, other way. Oops. Yeah, it's fiddly, isn't it?
Very fiddly.
There it is.
Ah. Sorry, it's difficult because I'm hooked up to too many things.
Okay, we'll come back to you in a minute. Let's go back to Mick and see what he's got.
Still got cloud, I'm afraid.
You look brighter in your shed.
Yes, it is getting brighter.
Right.
I've set the hydrogen alpha telescope. So
okay, splendid.
Hopefully we'll get something shortly.
Okay, it's come back to me now, so I will. I've got clear sky. I'll try and get. Oh, I did have. This is where we're cloud dodging. There's the sun from Jonathan again. Thank you. You found it again. That's very nice. You can really see how the moon is moving over the center there. Adjusting the position. See a few clouds going across in front. Okay, well, let's have a look back, Jonathan, at the situation from Canada, because it should be about time for the maximum of the eclipse.
Paul, you've still got Jonathan's phone pinned.
Yeah.
If you want to unpin that.
I've just done that. There we go. That's nearly there now, isn't it? You can see how the sun is going to be just a slightly larger disk in the sky than the moon. And that is because the moon is at the furthest point away in its orbit at the moment. Its elliptical orbit carries it slightly further away sometimes. And that's just where it happens to be today. And so it's about 13% smaller than it can be when it's at its closest. When we see it at full moon when it's at its closest. They call it a super moon these days because it's that bit larger. And so this is the opposite state where it's at its smallest apparent size and gradually moving across there. Won't be long before we see the complete ring right around the side. You can actually see the progress of it as we're watching. You can see that it's the two tips of the bright ring are moving around, and there was a little gap there through the surface of the moon. Of course, is covered in mountains, so every now and again you'll see the advance of the tips of the crescent sun peeking through the valleys between the mountains. There, it's doing it at the top now and at the bottom, and then it catches up. These are called Bailey's beads. You can see a few at the top there now. Brian mentioned them in his talk, so we're getting a very good effect there. There's a whole string of Bailey's beads coming now. Look, all round, and it's going to very rapidly join up right round to the full ring of fire, the annular eclipse. Isn't that spectacular, Matt?
That is absolutely amazing. It's a very small lump of rock covering a
live
very
on here at the moment.
star.
If you want to come round,
Yeah.
Would have to be cloudy today.
Sorry. That's a view from Canada.
Do you want to mute yourself, Jonathan?
Other parts of the world.
I just need to change the.
There's nothing to see.
So how are things looking for our observers? Do you have anything in Cambridge, Robin?
No, nothing except cloud.
Nothing but cloud. Shame.
By the look of it.
I think
you can't hear me, can you? Because oh yes, I'm switched on again. Yes, uniform cloud.
What's the situation with you, Mick? So now the ring of fire is over, look, and the moon has already moved across, and we've got the reverse crescent as the moon now is departing its alignment, and it's past the maximum and going to be the sun gradually moving out again. You're still seeing some of those Bailey's beads around the edge. Those little blobs of fire on the end of the tips. There's one developing. That's where the sun is shining through between a couple of mountains on the moon there, just as the alignment works out. That's amazing. Jonathan, can you take that away now?
Yeah, Let's switch away if they're doing adverts.
Mick, what have you got for us?
It's
Has that
still
gap
cloudy.
arrived yet?
It's bright. It's brightening up, but we're still
Soon, then,
I'll
soon.
get it back. There we've got on the edge.
I can't see anything. I've got complete cloud cover again. Just trying to see if I can get through it by turning the gain up.
Yeah, the screen's not big enough.
So-
Yeah, no, image quality isn't
Just-
good, but it gives
Robin, sorry, Robin, do you mind muting yourself?
I'm muting myself. Okay.
Cheers, thank you. We'll come back to you in a moment.
Here, the cloud's breaking, and I'm just beginning to see it on my screen here.
Oh, wonderful. There we go.
It's through some clouds, so I'm turning the gain up and giving it the best chance of seeing it, but still
it looks quite atmospheric through the cloud almost. I mean, maybe it's not as nice as the nice clear views. It looks, I don't know, I like the spookiness. It's really wonderful seeing those beads, like you said, just knowing that we're seeing the light filtering through the mountain ranges on the moon.
Yeah, thick cloud again now. Sorry.
Shame. How are things looking in Cambridge?
Yeah, we've got cloud cover. We can see it visually, but I wouldn't be able to get it through the telescope and the solar scope. So we can actually, the clouds are acting as a screen. Being very careful, but you can actually see it straight up in the sky.
Oh, we see Jonathan is doing something there which he shouldn't do, which is looking at so this was for demonstration purpose only. Please at home don't do this.
Channeling my best Donald Trump.
There it is back again for me. The sun's suddenly burst through, and now that's probably overexposing a little bit, but
no, that looks gorgeous. That looks
absolutely fantastic.
Yeah, that's really sharp. That's wonderful.
I can't see any sunspots. That might just need a little bit of a tweak to the telescope. Let's fiddle with some of the controls that I've got wherever it's hiding.
I think it's probably worth adding for people watching at home that the only reason we have eclipses is because our moon is absolutely enormous. The planet Earth has by far the biggest moon compared to its parent planet of any planet in the solar system. In terms of diameter, the moon is about a third the size of the Earth, in terms of the distance across it. The second biggest moon relative to its parent planet is Triton. That's a moon of Neptune, and Neptune is about 20 times bigger than Triton. So our moon is absolutely enormous compared to its parent planet. So yes, we do have this cosmic coincidence that the moon and the sun appear about the same size. But the cosmic coincidence is also thanks to the fact that we have this absolutely gigantic moon. Our enormous moon, actually, a lot of people are starting to think that having such an enormous moon probably played quite a critical part of the evolution of life here on Earth. The moon causes tides, obviously, and pulls the ocean around, and causes, in coastal areas, it causes tidal pools to form. And a lot of people think those tidal pools were really critical to the evolution of the first life forms here on Earth. So yes, while we might think it might be a kind of crazy coincidence that we can see these eclipses, it might very well be because that the moon played an important role in the evolution of life on Earth. So maybe if there are life forms elsewhere in the universe, maybe quite a lot of them have these enormous moons. So while eclipses themselves are very, very rare, it could well be that living beings might see more than their share of eclipses if it turns out that we're not alone.
Matt, I've just got on the screen here where the crosshairs are. Can you see there are some solar prominences?
And we can see some lovely prominences.
So that's material being thrown off the sun, isn't it?
That is, yes. So these are magnetic storms on the sun that are ejecting hot plasma from the sun's surface, and they look like very tiny little wisps on the surface of the sun. But each one of those prominences would be taller than planet Earth. So we are seeing on those little wisps are storms of completely mind-blowing proportion.
Just down here, yeah. That's well, I haven't seen any of those for a few years because the sun has been boringly inactive for quite a while. But so this is actually the first image of a prominence I've managed to get for some time. So not only have I got the superb image of the eclipse, which I'm going to keep, but some prominences as well. So that's excellent.
Yeah, I was going. This is a particularly lovely, a lovely image we've got right now. Yeah, eclipse and a prominence at the same time. That's incredible.
Yeah.
If the clouds get back on your way, Paul, I've got the photo I took while we were testing this last week, and you can see some sunspots. So that might be quite interesting then.
And any luck with the heliostat, Robin?
There's nothing doing at the moment. We're back to cloud, but we did have some moments with the heliostat, and I've changed the setup so it's better for cloud. But the sun's completely gone now.
Okay, well,
I think
there's no structure in the cloud even.
I think the blue patch I've got is going to be with you in 10 minutes.
Okay, so yeah, potentially, yeah, so potentially cut to you in about 10 minutes, Robin, when the patch of clear sky reaches you.
Okay, well, I'll give you a shout. I'll mute myself, but I'll give you a shout if something.
Excellent, yes.
I've got a video of the sunspots taken from last week, if anybody's interested.
That would be lovely. Let's. I'll stop sharing and we'll go over to Mick in Swaffham Prior then, shall we?
I've lost you now. Oh dear. Hang on. Seem to have lost.
Should we stick with the eclipse for the time being and then switch to the video?
I can show you a still photo of sunspots from last week while. Oh no, there we go.
Oh, very nice.
That sunspot was in the middle of the sun last week and has probably rotated around as the sun spins on its axis, and is probably lined up with the prominence that we saw on the limb, on the edge of the sun about now, because it takes about 7 days for the sun to rotate such that something in the middle makes it to the edge. It takes 14 days to cross the disk and 28 days or so to go right round.
Paul, should we stick with the view of the eclipse for now and then switch to these other things when we get clouded out?
Jonathan needs to stop sharing. Oh, he has done. Right, thank you. And I'll go back to my image here. Here we go.
Wonderful, yeah. Something because I feel like we're going to get clouded out at any point. I want to get as much eclipse as we possibly can.
Yeah, I'm just going to take some video recordings of this because it's superb. So I can record it onto my hard drive.
If you can do a bit of a perspective shift when I look at images like this. Of course, from one point of view, it looks like flat circles covering each other, but it's also, of course, worth remembering what we're seeing is spheres in space moving around. And if you think a different part of Earth is seeing a more total eclipse because the spheres have a different alignment, I always love it when you see the solar system as a you can visualize it as a real place with various kind of bodies moving around. It makes it seem so much more real to me.
Yes, I agree. You realise the sheer magnitude of it all, and the amazing coincidence, as you said, of the moon being 400 times smaller than the sun, and also 400 times nearer, so that it appears the same size, but just shows how vast the sun must be, really.
Yeah, absolutely.
There goes the cloud. But we can still see through it just about. That's only a small cloud, I can tell you, looking up into the sky with my eclipse glasses on.
So it's actually the fact that we have eclipses was also very, very important for the history of astronomy. So the ancient Greeks, way before we had telescopes and technology, the ancient Greeks were able to figure out quite a lot about the makeup of our solar system just using a bit of logic and mathematical common sense. There was a guy who famously measured the diameter of the Earth by using a stick and some shadows. The ancient, in the same kind of way, they were able to estimate the size of the sun and the distance to the sun by the fact that it covered the moon, because they had a rough idea, reasonably rough, of how big the moon was, and then from the fact of eclipses, they were able to use that to make a reasonably good guess about the distance to the sun, that relies on the fact that we get eclipses. If it wasn't for this cosmic coincidence, then the ancient Greeks would not have been able to estimate the distance to the sun. And I think it would have been probably well over 1,000 years until we were able to get a full sense of the scale of our solar system. So the entire history of astronomy owes a massive debt to the fact that we have these coincidental eclipses. I think if eclipses didn't happen, then it would have taken a lot longer to figure out the workings of our solar system.
So they were able to use it to work out how far away the moon was, or?
No, so they were able to work out roughly the size of the moon and the distance to the moon independently, often sometimes by using lunar eclipses. So this is a kind of eclipse called a solar eclipse, when the moon covers the face of the sun. But there's another kind of eclipse called a lunar eclipse, which is when the moon passes into the shadow of the Earth. So essentially, if you were sitting on the moon, you would get the Earth passing in front of the sun. And so by looking at lunar eclipses, they were able to figure out the size of the moon and the distance to the moon. And then once they knew that, the fact of eclipses let them figure out the fact that solar eclipses happen, allowed them to figure out roughly the distance to the sun. And it's because of this complete cosmic coincidence. If the moon was a bit smaller or a bit further away, then we wouldn't have had eclipses, and it would have been much harder to do that fundamental groundwork of understanding the scale of our solar system. And I think the history of astronomy would have taken a lot longer.
And I had a question that was emailed into me, Matt, which you might like to answer for us. This is one of our Astronomy Club members contacted me and said, why don't we get an eclipse every month if it's just the moon passing round on its orbit and going in front of the sun? Surely it should happen every 28 days.
That's a very good question. It's because even though, so when we draw the solar system, or when we make models of the solar system, we make it perfectly flat, right? So everything is orbiting around in the same plane. Of course, that's not actually quite true. There's a little bit of wiggle in the solar system, so things don't always line up as neatly as we might imagine. So yes, if everything was perfectly flat, then yes, we would see eclipses every month as the moon passes in front of the sun. But because the solar system isn't completely confined to a plane, things go around at slight inclinations, and so we have to wait for these much rarer alignments where everything lines up. It's because unfortunately, nature is not quite perfect. But it just means it's even more special when it does happen.
Yes, indeed. Okay, well, is the sun coming out for any of you other guys, or have I just monopolized the hole in the clouds here?
I think you've got all the sun at the moment, Paul. It's very cloudy and there's no sign of a break coming up.
I just saw it for 10 seconds.
It's cloudy here too.
Yeah. So from the YouTube chats, I think a lot of people are clouded out. It sounds like Scotland is absolutely clouded out. So yes, I think we've had some fortuitous weather here in Cambridge.
Yeah, it's funny little microclimate here in the mountains of Over.
We are coming back in business. Look, guys.
Over to you, Robin, then.
You can. Should we switch over to Robin, please?
Oh, briefly to Robin. Right. Can you see that? Everybody? Okay.
Well, yes, we are. We can see you, Robin. We can see very far.
Well, you can't anymore. Yeah.
No, I was going to say I very briefly saw some clouds drifting over the face of the sun. It seems to have
that's right.
Seems to have gone dark.
It seems to have gone dark.
Should we stay? We'll stay on you. Excuse me. We'll stay on you for a bit.
You can stay on me, and I'll try and be polite. I'll tell you what. I'm going to close. Can you close the down, David? Because it'll make it. Do you know how? Oh well, I'll do it quickly. Hold my breath, because it'll make it darker. Yeah, that's all. Which will help.
Where are we?
It's all gone dark.
Yeah, we have total blackness. Can you still see things, Paul? Should we cut back to you?
I can, yeah. Let me remove the spotlight.
Okay, we'll cut back to Paul for the time being, but then we'll be ready to go to Robin with a moment's notice.
Once
Yes.
you guys have got clear skies, give me a shout.
I'll switch myself off.
So there we are back again with my twin views with the DSLR camera with a solar filter, very much like Jonathan's foil-based solar filter over the lens. That's just an ordinary digital camera showing us the white light image, the small one, this one here. And that's sitting mounted on top of the telescope. And then the telescope itself is showing us the much enlarged view with its greater optical power. I can move this out of the way. We can still see those prominences over on the edge, yes, and they've changed a bit. It's they change every few minutes actually. There's now 3 groups I can see there down at the edge. I still haven't managed to spot any actual sunspots, but let me just try adjusting the telescope again. I can fiddle with the exact wavelength of light that I'm letting through by adjusting this control, and that gives us either a better or worse view of different layers within the top surface of the sun, depending on whether they're moving towards us or away from us. See, if you get it just right, you can almost make the sun look like it's made of orange peel, because it's bubbling away there. That's what I've gone for there. I can just about make out that sort of orange peel effect. But when the sun is very, very active, we get lots of dark spots and lines across it, and that will gradually increase over the next few years. So as the sun goes through its 11-year sunspot cycle, there'll be more and more. We're just coming out of the minimum at the moment, which is why it's so uniform and clear of them at this precise time. But I can see the sort of mottled surface there, which gives that sort of orange peel effect, which is the boiling surface of it.
Ah, great. Can we cut back to Robin, please?
Coming back to Robin now, I'll bring my screen and spotlight Robin.
I've just been casting around. The Greenwich live stream is completely black at the moment.
There's Robin. That's fantastic, Robin.
That's looking absolutely gorgeous from the heliostat.
Yeah. So there we are. We've got sun for a few seconds or minutes or something.
Excellent. I love the effect of the clouds drifting across the heliostat. That looks so lovely, doesn't it?
I'm just getting it all on the screen. There we are. Yes, I'm afraid it's a bit saturated, the camera. That seems to be and you can see the shadow of the camera on the side there. And you'll notice the image quality isn't as good as it is with the other system.
Yeah, that's looking wonderful. Yeah, that's looking incredibly clear.
Oh, you can see the cloud going by, can you? Which is the prettiest thing.
Yes, but yeah, the limb of the moon is looking very sharp against the sun. It's nice.
Yes. Oh well, there we are. Sadly, the image quality not quite with the other lens. Yeah, the color, is yeah, it's quite a fast. I do have a little stop somewhere that slightly improves things. I've lost. Yeah.
Lots of approving comments in the chat for all of our observers, I should say. People are very much enjoying that, especially people in. We have people watching from all around the UK and indeed all over the world. People in Scotland, Wolverhampton. Lots of people from India. GC Hung says, "Good morning from the Windy City by Lake Michigan in Chicago, Illinois, USA."
Ah, excellent.
One in Orlando is struggling to see it apparently. So yes, we are broadcasting from Cambridge all around the world. So we're really glad that you can all join us for this really special event. Very glad that the clouds have parted.
Well, we have a nice audience here in the Celestat room, so as well to enjoy the clouds. and the sun. No, that's impressive. And you can see the irregular limb of the sun because there are mountains and craters. Sorry, not on the sun, on the moon. The irregular limb of the moon because there are mountains and craters on the moon. And that's what gives us those bay leaf speeds effect when there's a solar eclipse. And the light just gets through a gap between the mountains when the sun is almost covered. Gosh, now we've got a clear sky. That is amazing.
And we're just saying, you can probably see blue sky behind us. And I think that's the blue sky that's over you. We're just missing it, I know.
Ah, yes. Well, I'm inside. I don't know what's going to happen. Sadly, this is a little bit saturated. Otherwise, you'd see the limb darkening. The fact the sun gets, we can see that in the room here, the sun gets a little bit darker towards the edge. And that proves the sun isn't a sharp-edged body. It has an atmosphere that's about 300 kilometers deep or so. So the light that comes from the edge doesn't come from quite such hot gas as the light that gets to us from the center, where we look physically deeper into the sun. Now, cloud rushing by at the moment. Yes, you do get the effect of speed. Sometimes I've seen cloud moving in opposite directions, and occasionally I've seen from here an aeroplane fly across, which is quite exciting. That tends to happen more in winter because the sun is lower in the sky, and so more likely to for an aeroplane to cross. It's going through more atmosphere.
I had a similar thing, Robin, with a flock of geese, which made me jump rather.
Yes.
I think it's worth pointing out as well for everyone watching that even though from our point of view, watching the moon cross the face of the sun looks like this very slow, stately procession, in reality, the moon is traveling at more than 2,000 miles an hour as it orbits around the Earth. So yes, things in space that look to be very, very slow and ponderous are actually very, very fast indeed sometimes.
Yes. Yeah, well, gosh. Now it gets boring because, you know, there's no cloud rushing across, so all we see is a nice chunk out of the sun.
So how incredibly boring, just a solar eclipse.
Yes, well, it's much more exciting when you're desperately wondering whether you get to see anything through the clouds. Yeah, I can but you won't be able to just see some sunspots.
Whereabouts are the sunspots on the disk, Robin?
Yeah, can you
point out the sunspots? There's a group of sunspots just there, about 4. And yesterday there was one that I can't see down the bottom here somewhere. Oh, there, yes, it's moved over. Yeah, this lot here was down there, but you won't see them, I think, on your on my video camera.
No, I'm looking at them on my solar scope image, and I think I can see them just as slight disturbances. I've probably not got the setup quite right.
Yeah,
a bit overexposed or something. Because I'm sat here getting a suntan at the moment. It's really quite bright. Being through the slot of the observatory. How's it going for you other guys? Jonathan, have you got any sunshine yet?
I think we've got some sunshine coming. I'm just trying to get the telescope aimed in the right direction.
Yeah. Oh, yeah.
I should say, just to people watching as well, just to do the obligatory YouTube thing, if you are enjoying this stream, do consider subscribing to our channel. So this is coming to you from Cambridge University Astronomy. We do live streams for all kinds of astronomical events like eclipses, and during the winter, we have a series of public lectures all about astronomy. So starting in October and running through to March, once a week we do some live streamed stargazing, and you can learn about what's going on in the world of astronomy research. And over the summer, we're going to be doing various talks for children. We're going to have a series of astronomy talks talking about different kinds of things aimed at younger audiences. So if any of that sounds interesting, do consider giving us a subscribe.
Right, I've just put a yellow filter over in front of my beam, which has cut down the chromatic aberration quite a lot, which helps certainly with our view.
Yes, that's very sharp, Robin. Now.
Yes, I'm pleased to be able to see those mountains on the moon. That is quite nice.
Yes, you can see the fact that the moon is not. Yeah, you can see that it's not perfectly round.
Oh my God!
Lovely.
Just looked up the tube and it's full of cobwebs. That's the trouble. Yeah, well, we couldn't have hoped for better than that. One of the wonders of nature.
Some clouds again.
Clouding, yeah.
So this is the best solar eclipse we're going to see in the UK for a little while. I think there's one happening towards the end of next year, but it won't be quite as impressive as this one. The next really impressive one that we're going to see from the UK is in 2026, where if you're down south, we're going to get to about 98% of totality. So not a full solar eclipse, but about 98% of a full solar eclipse, and that's going to be in about 5 years' time.
Oh my God!
Take a trip to the Shetland Islands, I think. Do you? Is that?
No, down south through northern Spain is totality.
Oh, okay. The other way.
Oh, well, I'll be 83 by then. So that's no good.
Yeah, I think there's I think if I remember, there's not going to be any. I think the next total solar eclipse from the UK happens in about 2130 or something. So yes, a little while.
It's quite nice. Yeah, see, I'm going to walk in front of it just to prove it really is a shadow. I mean, projected.
23rd of September 2090 is the next total eclipse we'll get in the UK. So a little while to wait, but we have a lot of these nice partial eclipses to enjoy before that.
I have a picture at last.
Excellent. Shall we whiz over to Mick in Swaffham Prior, where the sun has finally come out? Let me, yeah, that's it. You do that, and I will take the spotlight away from Robin for a minute.
So just to say, there have been some people asking on YouTube if we've missed the Ring of Fire. So we never had the Ring of Fire effect here in the UK. We had around 30% cover at maximum. But in northern Canada, they did have a Ring of Fire, which happened about half an hour ago. So you can either skip backwards on this video or check out some live streams from Canada and you can see the Ring of Fire. But yeah, we broadcast it. We hooked into a stream from Canada about half an hour ago where there was a very nice Ring of Fire effect. But now, yes, it is now past maximum and the moon is on its way out away from the sun.
That's good, Mick. What telescope is this?
That's an 80 millimeter with a Herschel wedge.
With a Herschel wedge. So that's a partially silvered mirror that's deflecting some of the light to your camera and letting the rest go straight through so that it doesn't catch fire.
Yes.
Yeah.
Right. Just going to play around with the settings a little bit. I was looking for the sunspots, but
they're almost invisible with my hydrogen alpha telescope. There's just a slight ripple on the surface of the sun is all I could see. But different instruments pick up different things, don't they?
Yes.
A lovely effect with the clouds whizzing by just at the moment, but I bet it's driving you crazy while you're trying to adjust the contrast.
Yes.
I've now lost the sun at this end, so it's very timely that I guess the gap has arrived over you, and I've now got cloud. So
I've lost it now. Oh, coming back.
Coming back.
I've got an image now, Paul, as well.
Will it last? We'll stay with Mick just for a minute because he's got an image. Those clouds really are scooting by.
It's
And even as
70
we're
frames.
talking, we're gradually seeing that sliver of the moon getting thinner and thinner, aren't we? As it's
Yes,
We've
it's
still
running,
got a nice image here.
it's running at 70 frames per second at the moment.
I think I manage about 4 on this laptop.
Ah,
But we've lost it.
lost it.
John, shall we go to Jonathan while you recover your situation? Just because we haven't seen much from him yet. Jonathan, do you want to just have a go? Show us what you've got.
Yeah, you just have to pin my image on the telescope, Paul.
Right. If I do this, I think this is the trick, isn't it? Okay, so we can see the sun with the bite out of it there down at the nice yellow color from your particular setup. And as we said, this is you've got the mobile phone in some sort of cradle looking through the eyepiece, have you?
Yeah. Sorry,
So,
I'm on mute.
just to say very briefly, quite a lot of people in the chat are asking if the it's going to be visible from their location. So I'm going to pop in the chat the map of the eclipse, so you'll be able to see where in different parts of the world you can see this.
Splendid. That's not bad, Jonathan. Not bad at all, given the mechanical contrivance that you're using.
Can you hear me at the moment?
Yes. But not now.
Yeah, sorry, I'm struggling with muting and unmuting. I'm struggling with muting and unmuting. I'm quite pleased to see the contours of the moon.
We've got it quite nicely here still at the heliostat.
Cool. Can we cut back to Robin?
Yep, sure.
Okay, so for everyone asking if you can see the eclipse in particular countries, I've just put a link in the chat where you'll be able to click, and there's a map of the entire world, and so you'll be able to pop your location in there, and it will tell you exactly what you can see.
Yep, we've got a bit of passing cloud again, as I think you can occasionally see.
Yeah.
Yeah, and it is quite clear that the moon is moving away.
Yeah,
that's quite clear now.
Another question that came in to me via email, Matt, was do we see eclipses on other planets?
Well, so on other planets, certainly the moons will pass in front of the sun. But like I was saying earlier, our moon is absolutely enormous compared to its parent planet. So for most planets, they won't get a real eclipse effect. So for example, Mars has 2 very tiny moons called Phobos and Deimos. Both those moons are a few hundred kilometers across, and so I think you'd need a very good telescope to see the tiny speck of those moons passing in front of the sun. So yes, you do get eclipses, or you do get the moons passing in front of the sun on other planets, but it's only on the Earth that you get this particular effect where the moon and the sun are the same size.
You get some nice eclipses on Jupiter. We see dark shadows of the moons of Jupiter on the surface of Jupiter, but not a great place to observe eclipses from.
No, exactly. Yeah, I think it was Arthur C. Clarke who suggested that in the far future, if humans have colonized the entire solar system, people still might come and visit Earth to see eclipses. It might become a bit of a tourist hotspot because it's the one place in the Earth that you can stand. It's one place in the solar system where you can stand on a firm, comfortable surface and see this beautiful eclipse effect.
But we've only got 200 million years because the moon's moving further away. And I think there'll be no total eclipses in 200 million years' time.
That's true, yes. Enjoy them while they last.
I've got a nice image of the actual crescent part. You can actually see some detail on the moon, I think.
Okay, why don't you go and have a look at that, guys?
Yeah, just switch that over. Where are you, Mick?
Oh, clouds have come. Oh. No, I'm afraid. Let me just see if I can brighten it up a bit. You can actually see a little bit of detail.
Oh yes, you can see the ragged edge of the moon there. That's nice.
Yes. Well, you could have done, but I've lost it. I've stopped sharing, Paul.
Right. Sorry, I'm just attending to a flat battery.
Technical difficulties. Should we cut back to someone in the time being?
I've got an image at the moment if you want it.
I like the washing on the line. Matt, you're doing a great job as compare.
I think we're all doing a very good job. I think it's just coming together, and the weather most of all, right?
Yeah.
Someone was asking.
Jonathan.
Oh, that's my head. It'll be. Yes. See that.
Someone was asking in the chat about the solar eclipse of 2026. What kind of totality will they get in 5 years' time? So from Scotland, you should be able to get around 90%. The figure I've seen is about 91% from Aberdeen. So yeah, even as far north as Scotland, you'll still get about 90% of the sun's coverage. That goes up to about 98% down in Cornwall and 100% if you're in northern Spain. And that is in September. Oh no, sorry, 12th of August 2026 is the date for your diary.
I've got an image of the sunspot now, if anybody's interested.
Yes, I didn't. I mean, flipping spider moved in when I wasn't watching. I mean,
Okay, let's flip over to Mick.
For some reason, I lost the ability to zoom in now.
Just there. See if I can get. Just there, if you can see it when the clouds clear. It's a very small one.
Oh yes, I can see it.
You can also see. You can see some of the surface detail around it.
So for everyone watching at home, that is a sunspot, which is a dark patch on the surface of the sun. And it's dark because it's a little bit cooler than the surrounding temperature. So the sun is hot. The surface of the sun glows because it's hot, around 6,000 degrees. And sunspots are a bit cooler than that, which is why they appear black. Of course, saying a bit cooler is in relative terms, they're still about 4,000 degrees rather than 6,000 degrees. So still very, very hot, but cooler than the surrounding plasma.
I can see it was there. Oh, I can see it on here, so you can't see it there.
oh, that's a nice view.
That's beautiful. That's looking fantastic.
Whose view is that?
It's Mick from Swaff and Pryor.
Oh, lovely. Yeah.
80mm refractor
Yes.
and a Herschel wedge.
And you can see the limb darkening. I think your dynamic range is better than mine with just a webcam.
And you can still see the sunspot clearly there. Look.
Can you describe quickly what a Herschel wedge is, so the people at home can understand what they're seeing?
It's a special prism on the back of the telescope, which only allows a certain amount of light to go into the camera. The rest of it goes through the back of the wedge onto a heater screen, so it doesn't damage the optics. It's just reflecting a small amount of light up into the camera.
Yeah, no, pleasure. Well, thanks. Yeah, volunteering. Yes. Yeah, indeed, yes. And I look forward to demonstrating the spectroscopy sometime.
Oh, I look forward to that.
Yes.
Can we mute Robin, please?
Am I not muted? Oh God.
No, sorry. Because hear you off having other chats. So it's interesting the range of technology that we've got here today, because of course we're all trying to do the same thing, right? We're all observing the sun, but the ways in which we're doing it are very different. We have some people with solar filters, which is essentially just blocking almost all of the lights from the sun before it reaches their sensor. We have Mick with his Herschel prism, which is a wedge of glass that sends most of the sun's light away in a different direction and only refracts a small amount that we can use. And then we have Robin with his heliostat, which is doing something very different and projecting the image onto a screen. So it's kind of amazing to see all these different kinds of technology and these different ways of viewing the sky.
And indeed, the scope that I've got is different again, in that it's just letting one wavelength of light through, corresponding to the vibration frequency of hydrogen, which of course the sun is made of, and it's rejecting all the other wavelengths, which is why my image looks orange, because we're just looking in that one wave band, whereas the other guys are looking in all the wave bands and looking in so the sun looks much more white.
I'm just going to switch over to hydrogen alpha. So
yeah, that's what I've been using. But let's have a look for yours, hydrogen alpha view, Mick. That would be excellent. I still can't find this sunspot on mine. I must have not quite got it in focus or something. But the sun's back out again here now.
So for anyone with a bit of a physics background, so what H alpha is the light that you get when a hydrogen atom goes from a very excited state to a slightly less excited state and emits what we call a photon, a particle of light. So if anyone knows A-level physics, it's going from the third energy level down to the second energy level. But yeah, a more simple way to put that is when an energetic, excited hydrogen atom releases some energy, and the atom calms down, and the energy disappears off in the form of a photon, and then they are collected by our telescopes here on Earth.
Can you stop sharing me, Paul, please?
Yeah, I'll take it.
I can't do it on this end.
Who's got a view? It looks like the heliostat has a good view still. And you've got a good view, have you, Paul?
Yep, there we go. Getting thinner. I'll take the spotlight off, Mick. There we are. Oh.
Seem to have lost the link somehow.
Oh no, it's people watching from Thunder Bay in Canada, apparently hoping to see the eclipse, have been defeated by a thunderstorm. So yeah, I'm sorry to hear that, guys.
I finally managed to get a really well-centered view of it, if you want to go to me briefly.
Yep, okay. Let's flip over to Jonathan with his very yellow view of the sun instead. So I've stopped sharing. You should be able to take that, or no, I need to do the spotlight you, don't I? There we go. So many things. Oh yes, that's nice. That's more naturalistic looking than mine, because as I say, mine is looking at this wavelength of hydrogen light, and yours is much more a natural color, isn't it?
If I zoom in, then the contrast changes.
Yeah.
I can't see any sunspots either.
You can see the irregularity of the shape of the moon when you zoom in on it, though, Jonathan. It's you can see the sort of bumps and lumps of the rounded mountains on the moon.
Yeah.
Very much the case that the moon doesn't have the sort of tall, spiky mountains like we have in the Alps and the Himalayas and so on. It has much more rounded peaks to the mountains.
Just to interject, I think some people are joining the stream and just want to know on a quite a basic level what they're seeing. And so what we're seeing here is a partial solar eclipse. And so that happens when the moon passes in front of the sun from our point of view. And so, yes, the big bright thing is obviously the sun, and the black thing is the moon, which is much, much smaller and much, much closer. And so, yes, that little bite you see out of the sun, that is the very edge of the moon. That's just blocking the sun from our point of view.
That's a very good image there now, Jonathan. Got it much better lined up.
Yeah, that's looking fantastic.
Yeah.
It's amazing what you do. Manual control. There come the clouds.
Inevitably.
That's all for now from here.
Should we go back to Robin?
Hi, yes, well, we're looking good here. No, we did have a bit of cloud, but it's passed. And so we've got quite a nice image. Tiny bit of jitter. Yes, I just wished I'd got a slightly better camera that isn't so saturated, but
no, it looks wonderful. Can you tell us, so which way is up on this? Has the instrument flipped the image in some way?
Yes. Well, I think at this time, north is up, but east and west are flipped. That is
yes, I think you're right, Robin. I'm looking at it directly with my Eclipse glasses, and the bite is at about on the clock face. It's at about 10:30 for the center of the bite. So yes.
Yes, that's right. So west is on the left-hand side as you look at my image. Yeah, that's correct. Yeah. Yeah. Yeah, that's to do with the going through the mirrors.
Mm.
And yeah, no, well, that is as good as it gets, I think, in terms of quality, which is very nice, in terms of being able to see the sun and see the moon moving away.
Yeah, that is absolutely spectacular. I couldn't have hoped for any better. That is absolutely spectacular.
Just saying something about eclipses, you said briefly, somebody asked, why don't we have an eclipse every month? Well, we would if the moon orbited the Earth in exactly the same plane that the Earth orbits the sun. And so we only get eclipses when the moon's orbit is passing through the plane of the Earth's orbit. And then you might say, well, we should always have eclipses at exactly the same time of year, each year. But the problem there is that the moon's tilted orbit precesses, so it slowly rotates around the Earth. And so that makes life very complicated. But you will often find that we get a lunar eclipse and solar eclipse within a couple of weeks of each other. And that's because we're at a time when the orbital, the moon is close to that intersection of orbital planes. Gosh, it's so much easier to illustrate this. Now I think you can see the cloud roaring through, adding to the drama. And you're seeing the silhouette of my camera.
So in astronomy, there is something called, I think they're Saros cycles, which are periods of about 18 years or so. And so roughly every 18 years, the Earth, the Moon, and the Sun return to a pretty similar configuration. And so you can use that to kind of estimate and predict future eclipses. And they were doing that as far back as ancient Babylon. So people would predict that if you saw an eclipse, there might be a reasonable chance of getting one in about 18 years' time.
Yes, of course, the problem with that is absolutely right, 18.6 years. The problem is that solar eclipses are very localized. So they would be right. There would be an eclipse somewhere on Earth, but not necessarily visible in Babylon, to add to the complications.
Yes, exactly. I always think it must have been absolutely terrifying before modern times, because these days, of course, we can just enjoy the spectacle of the natural world. I think before they had a good understanding of how the solar system worked, it must have been incredibly alarming to see an eclipse. And I think if you were the person that could predict that an eclipse was coming, I think you would be seen as a person of phenomenal knowledge and power.
I know. I think it still is quite terrifying. And it is well worth going to see a total eclipse. And don't be fooled, a 99.9%, there's still enough light to get around the sun. But seeing a total eclipse is a sort of one of those, if not life-changing, it makes you think about the world we live in. And the idea of seeing the orb of the sun black in the sky is still quite terrifying. And I noticed at the eclipses I've been to, at the end of the eclipse, everybody applauds. And I think that, and cheers. And I think that is partly out of a sense of relief that the sun has come back.
Right. It's some incredibly primal thing that we see the sun return and we get to carry on living.
Yeah, exactly.
I have another image of in hydrogen alpha with a few filaments and some more detail on the sun if you wish to have it.
Oh, yes, please, Mick. Let's go for that.
With me.
We'll share your screen.
Have we got me?
Yes, there we are.
If you look at this, let me just adjust it slightly. There's some filaments there on the surface. On the surface just there, if you can see, and there's the sunspot.
Yeah, I can just make the sunspot out if I get right up close to the screen. The filament's eluding me at the moment. I think it's possibly... I'm
going to increase the gain to get...
No, you want to go the other way, actually. That's way overexposed for me now. Go. Oh, you've got the prominences down at the bottom there nicely. Yes.
Oh, yes.
And another one there.
Just to remind anyone that missed when we talked about the prominences earlier, what we're seeing here are enormous storms, magnetic storms on the sun that are causing huge amounts of this burning hot plasma at about 6,000 degrees to be kind of blasted off into space. And they look like these little wisps from our point of view, but each one of those prominences, each one of those little wisps is much bigger than planet Earth. If you give a planet Earth on this picture, it would be a very tiny dot. So yeah, we are seeing something of very, very extraordinary power and ferocity, even though they look like little puffs of smoke.
We go back to the surface. If I reduce the gain, you'll see more surface detail. There we go. So there's the sunspot.
If you think it would be of any interest, I could show people the pinhole camera and its projection.
We'll come to you just in a moment, Jonathan, I think then.
There's a nice effect, talking of pinhole cameras, there's a nice effect you can get where, so a pinhole camera, for anyone that doesn't know it, if you shine the light from the sun through a hole, you can make an image of the sun on a screen at the back. Sometimes the light shining through a tree's leaves can cause a pinhole camera effect. And if you look at the floor under a tree during a solar eclipse, often you can see hundreds of little images of the eclipses as the gaps between the leaves act as pinhole cameras. It's really amazing to see.
The other thing you can do with a very small mirror, the use of sort of compact mirrors that women used to have, if you shine the image of the sun onto a distant wall with a small mirror, you will see that it acts as a pinhole, and you can shine into a dark space and see quite a dramatic, during an eclipse, image of the sun, a crescent.
Okay, shall we come over and have a look at your pinhole camera then, Jonathan? If Mick can stop sharing.
Yeah, you'll have to.
Oh, I'm sorry, not paying attention. I'll go to.
You can highlight me non-telescope.
Highlight you non-telescope. Okay.
That's not the sun. That's that one.
That one.
So here's the pinhole thing. So my glamorous assistant Chris is going to help with this. So if we hold that up at that sort of angle, and I put this in front of it, you can see that little white dot. You probably can't see anything actually, but move right close. Can you see that tiny little white dot in the middle?
Yes.
Yeah, and it's probably a bit too near the end of the eclipse, but there is actually a slight change to the shape of it, so it's no longer circular. You can see a little bite out of the edge of it. And that's simply a little bit of tin foil with a pinhole in it. Very exciting. I think it's bigger, but it gets fainter. There we go. I did try it with the colander, but all I got was colander. It's the holes aren't small enough.
You need to invest in higher quality cooking equipment.
Clearly.
Yeah. I just got the sunspot then, and then a cloud came over for me again. Oh, so close.
Yep, I've got some very nice clouds streaming past. Oh, and I've almost, yeah. Oh, you're silent, Matt.
Sorry, yes, if you can catch to Robin, it's looking very atmospheric as the clouds drift up past the sun. You can tell we're just in the last moments of it, right? Is it about 20 past 12, is it supposed to finish?
I think that's right, yes.
So we've got 10 minutes, yes.
10 minutes left.
And yeah, clouds sweeping by. You can see it in the surrounding sometimes.
Oh, it's very, very ominous.
Yes. I can still just see the sun from where I am. And here it comes, yes.
We can clap now the sun's returned.
The boiling, seething cloud does seem to be moving fast.
I'll just pop back over to my observatory here for a moment. There I've got the moon on one side, just as a thin sliver out of the sun, and diametrically opposite on the other side, you can clearly see those prominences, those huge eruptions of hydrogen gas flaring off the outside of the sun over here.
That is an incredible image, Paul. That's absolutely amazing.
Yeah, I still haven't found the sunspot, but it's there somewhere, they tell me.
Yes, sunspots don't always appear with such high contrast in H alpha, I've noticed.
I turn the exposure down and drop this down. there's a hint of the sunspot about here. Does that sound about right to you guys that have seen it?
Yes.
Oh yeah, okay.
Yes,
Maybe I just got it overexposed. But
and you've got some luminous faculae on the surface, just inboard from your prominences there. Yes, which is very nice.
Brighter white patches.
Yes.
And another one there, Robin, I think.
Oh, is it? Good. I thought that might be a mark on your camera, but that is a very conspicuous one if it's
we can
real.
test that hypothesis. What I'll do is I'll just nudge the image a little bit and see if it stays where it is.
No, it moves with the sun. That's very nice.
So again, for anyone at home wondering, that bright spot, Robin called it a luminous faculae. What that is, that's a little bit of the sun's surface where the magnetic field lines have all become very, very concentrated, and you get this little bright spot on the surface of the sun.
Yes, I might try and chase that with the spectrograph. You might see emission lines. You might even, see calcium in emission. Oops, I'm disappearing.
One of the effects with the telescope I'm using is that the heat from the sun changes the position of that I need to adjust the focus to all the time. So when the sun goes in, the telescope cools down and it changes the focus. And then the sun comes out and I have to go back the other way. So it's quite fiddly. But yeah, if we turn that gain back up again, we'll see those prominences on the edge. Bring that back to there. There they are. It overexposes everything on the surface of the sun, but you can see those bits sticking out at the edge there. Just looking, see, some cloud. See if there are any others anywhere else, but just dropping the gain back down again.
Someone is asking about the height of those solar flares, and I think I would have to calculate it properly, but somewhere around 10 or 20,000 kilometers.
They're about the size of the Earth.
Mm.
Yeah, at that sort of scale. That's right. So about 20,000 kilometers for the height of them. Really quite.
It's amazing, isn't it? When you see these little puffs of smoke, and the entire Earth could fit inside that puff of smoke.
Yeah. Of course, they're not made of very much, are they? They're quite thin, really.
Yes, exactly. It's very, 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 very rarefied, very, very thin plasma. Of course, they glow very brightly. They look quite substantial because they are very, very hot, and so we're seeing all the radiation coming off this hot plasma. But yes, there's not very much to them at all.
Okay, well, you've got a fantastic image there, Robin, so I'll stop sharing. We'll come back to you.
Okay.
Just a few minutes more.
A few minutes more.
Enjoy it while it lasts.
A few minutes more. Ah, yes. Nice and clear.
So yeah, as we were saying at the start, so yeah, in terms of dates for your diary for future solar eclipses, there's one towards the end of 2022. So in October 2022, there's going to be an eclipse, maybe not quite as good as this one, but another partial in 2022. There's a pretty decent one in spring 2025, between 40 and 50%, depending on where you are in the UK. And of course, 12th of August 2026 is the big one, somewhere between 90 and 98% from the UK, and then up to 100% total eclipse if you go down to northern Spain. So there are a few coming up before the big one in 2026.
I've got another sunspot group if anybody's interested. There's two sunspot groups now visible.
Okay, let's have a quick look. If you just share your screen, it should work. I should not have to do anything.
Oh,
See
Cloud.
Robin's image inset.
Oh dear.
Aha, Cloud.
Sorry about that. But there's a group of 3 spots at the top and the other group at the bottom. I'll stop sharing.
Robin's, well, yeah, Robin's got Cloud as well, actually. So
if it comes back, I'll let you know.
let's just give us a shout. I'll pop back to mine because I'm in the clear. This is the huge advantage of having several observing stations.
Certainly is.
Yeah, Paul, I've got a good image as well if you want to try something different.
Okay, yeah, I mean, that's rather nice. The moon's getting really quite thin here now, and we're still seeing those prominences over on the edge of the sun over here. 1 or 2 wispy bits of cloud going in front again. So I'll stop and go over to Jonathan. And to do that, we have to do this.
That's a beautiful image, Jonathan.
It's just that last sliver there. It won't be long, will it? I make it 12:18, so I think there's 2 minutes to go or thereabouts. I can't see anything at all now because I've got cloud.
Yes, I've got cloud too.
I've got a full disk at the moment.
Good.
Wonderful. I can't believe the weather was so kind to us in the end. This morning I was staring at skies that looked like they were about to rain, and I thought the whole thing was going to be a bust. We've had such good luck here.
Yes, I was being interviewed on the radio and not holding out much hope for it at all, but that little tiny gap came at just the right time, didn't it?
Exactly.
I've got a nice view of the sunspots at the moment.
Okay, let's go to you, Mick. We can leave Jonathan inset in the side there.
I'm sharing, but Jonathan's still on the screen.
Okay, I'll take him away.
Right, there's a group there of about 1, 2, 3 spots, and there's a group at the bottom there.
We've got rather too much whizzing cloud just at the moment, so
it's just there.
There we go. Has anybody got an image? Because I haven't.
I've got an image.
Okay.
We're nearly at the end.
Yes.
Yeah, see just a sliver of moon there across the face of the sun.
I've got an image as well.
I was going to say, if you're really clever, you could follow the disappearance of the moon from one observer to the next.
That's a really good idea, isn't it?
Well, yes. Yes, it is getting very... I mean,
So
the best way
I guess it will be me first.
See the two points of the crescent kind of closing up on each other.
Yeah.
That's the way it'll go.
Unfortunately, I don't think I'm going to see it.
Yeah, I'm very lucky.
I think nature has now intervened properly for me.
Okay, we've still got Jonathan, and we've still got the heliostat. Should we maybe? I think as we're in the last, should we just stay with the heliostats until the end? Because it looks like things are looking pretty good, and we've got about a minute to go.
Yeah.
I'm clouded out.
Oh, I'm back. I'm back on again temporarily, but yeah, very thin sliver. I'll shout out when I see it disappear completely.
Okay, that'll be
if you see it, and we'll stay on the heliostat.
Yes, I can point to the two crescents closing up.
So who's the easternmost and westernmost of our observers?
I'm the eastern, I think.
Okay.
And I'm the western.
So it should disappear for Paul and then Cambridge and then Mick.
I think I'll be used to
Yeah.
Robin. But,
Whoa. Oh yeah,
got-
that's very pretty.
I've got cloud.
What we wanted.
Oh, I think you could see it just disappearing below the clouds.
There, oh, I think you can still see.
Yeah, it's still there.
Yep, it's still there. Oh, yes. I can't see it on the screen at the moment.
Okay, should we?
Oh, yes, here it comes. Here it comes.
There we go.
Oh, and you can see it getting smaller quite rapidly now.
You can. Oh, it's almost in real time. You can see it changing, can't you?
Yes, you can. Yeah. Oh, that's beautiful. That's very sort of atmospheric.
Mm.
Well, I've still got a thin disc.
Oh yes, survive.
Yeah.
It's like, yeah, Jonathan still has a sliver, right?
yeah, still a little bit.
Mm-hmm.
Yep, my sliver's getting smaller. Oh, well, bit of cloud, but it's going to come back, I'm sure. It's thin cloud. There we are, down to very thin sliver there. Still there.
Oh, there we go. Beautiful view.
Exciting. Yeah, the cloud is still thinnish. Yes, it's going to come back. Says he optimistically.
We could cut to Jonathan. Jonathan's got a very nice view, I think.
Ah.
Yeah, it's still hanging in with the cloud.
Yep.
Jonathan, oh yeah.
Still
just a sliver.
Oh, it's cloud.
Sort of shaving of moon taken off the sun there.
There we are, still there. I don't know where you are now, but I'm
back with you, Robin. Oh yes, very tiny bit.
Yep.
I am now clouded out, so
I've got a full picture.
Maybe I'm going to be. Who's going to be the lucky one?
We're almost at the point where if you didn't know there was an eclipse going on, you might not notice.
I know. I don't know if you. I've darkened the room, so hopefully I can still just see the sliver through the passing cloud.
Just a tiny bit there on Jonathan's, the very slimmest bit.
We have seconds to go, don't we?
Yeah.
I've lost my image. Possibly when it comes back, it'll be gone. Let's see. Come on, sun, come back.
I've just.
Oh, here we are. No.
Okay, so we're on Jonathan right now. He's got quite a nice view of it, and it's
just seconds to go now.
I think it's just finishing now, isn't it?
I think it's just finishing now.
There we go.
Mine is still visible. Still visible.
You can see. You can still see. Can you, Robin?
Yes, I can. I'm standing up by the screen. I can still see.
Okay, I think that's you over and done with, Jonathan.
Let's see. It's any second.
Okay, let's cut to Robin. There we go.
Well, oh, you'll be lucky. Yeah, there it is. Still just there. But I think it's gone. It's almost going. It's still just visible.
Okay, Mick, I think you might be the last man standing. What have you got for us?
I've got a full disc.
Yes, it's gone for me now.
Okay, so it's finished in Cambridge. Okay, let's cut to the east.
Are you still seeing it? That's wonderful.
Oh, I'm not. What is this? Oh, sorry, that's the heliostat.
Do you want to share your screen, Mick?
I'm struggling at the moment. I've lost it.
Oh, okay. This might be it then.
Yeah, that was probably it. It's certainly gone for me, and the sun's gone as well.
Yeah, me too.
Lots of sun in Cambridge now.
Yes, I'm in Clough again.
Yes, I'm certainly in Clough.
Yeah.
Oh, well, a glimpse. Well, here it comes. We are. I don't think you can see. I'll just put my red lights out. I was seeing the sun, but
I think it might be time to call it. Do you agree?
I think
so. So well done to the observing team. Thank you so much. I think we managed to put on a fantastic show, dodging the clouds there. So thanks ever so much for making the effort on behalf of everyone watching to join in and spend 2 or 3 hours setting up and putting this show on. I think it's been wonderful.
Yeah, exactly. Thank you so much to everyone all around the world. It's been wonderful watching the chat and seeing people all around the globe joining in. And so, yeah, very sorry to people that were clouded out or thunderstormed out. But we're really glad that we were able to share this. And thank you to all of our observers. I think it was very lucky that we were able to spread out over some distance and use that strategy to dodge the clouds.
It worked very well.
It did.
Thank
and
you, Matt.
Yeah, and thank you very much. Thank you very much to all of our observers, Paul, Mick, Robin, Jonathan. Who am I leaving out? Thank you to Brian for telling us a bit about historical eclipses. Just to do the YouTube thing, do consider give us a like, give us a subscribe. We will be doing more astronomical live streams, and we keep telling you what's going on in the world of astronomy research. So if you're interested in this, give us a subscribe, and we'll have more interesting things for you in the future. Great. See you again, guys. Have a good day.